Hello everyone and welcome back to Explore Engineering. In today's video, we will see the pulse width modulation. Already we have done with one program or one experiment of this pulse width modulation with different program. In this video, we'll see a program where we will set the value for 25% of the duty cycle, 50% of the duty cycle, 75% and 100%. Here, this is the formula to calculate the average voltage. That is the duty cycle into 5 volt divided by 100. And average voltage, it is also equal to PWM value into 5 divided by 255. When you are using the duty cycle, you need to use this formula. And when you use PWM value, you have to use the second one. As Arduino PWM uses 8-bit values, it uses 8-bit values from 0 to 255, and the logic level, that is the voltage, will be 5 volt maximum. Okay, now here you can see this is the example of the PWM signal. This is the T on time and this is the T off time. Okay, this is the T off time and total time period is T on plus T off, that is the total time. So here you can get the duty cycle by using this formula, that is T on divided by capital T, that is the total time period into 100, which will be expressed in percentage. Now here when you give the value or set the value as 64, you will get 25% duty cycle and the average voltage will be 1.25. Okay, like this here. Then that is the signal is on only for 25% of the total time period. Then next, when you set the PWM value to 127, you get the duty cycle as 50% and the average voltage will be 2.5 volts. That is, the signal will be on only for half duration of the time period, that is 50%. Next, when you set the value for 191, that is the PWM value for 191, you will get 75% of the duty cycle and the signal will be on only for 75% of the total time duration. So here that is time period, not duration, time period, and the average voltage will be 3.75 volts. Then for 255 it will be 100%, duty cycle will be 100% and the signal will be on for all the time periods. So here the average voltage will be 5 volt. So higher the duty cycle, higher the average voltage, and more power and more brightness, and you will get more speed. So here again this is the same thing, that is the signal will be on for how much, 1/4 of the time period, here half of the time period, and this is 3/4 time of the time period. Okay, this one. Now these are the components which are required for the PWM experiment using Arduino UNO. You require Arduino UNO, then LED to observe the brightness variation. You need a resistor, buzzer, then DC motor, servo motor, breadboard, jumper wires, USB cable. You need oscilloscope to see the signals. Then you can use the multimeter in order to see the voltage, average voltage. Okay, and this is the connection. You can connect one element at a time. These all are the output elements, that is these are all the actuators. So here you can use one at a time or you can connect all at a time. Now here these are the PWM pins. As you know, we have seen this in the previous video, that is these digital pins are used as the PWM pins, which are indicated by this tilted sign. Okay, that is here, this sign. Now here Arduino UNO, it provides PWM on 6 digital pins and these pins are marked with tilt. So you can use the analog right pin value whenever you are using these digital pins. Okay, so here you need to use this command or this instruction whenever you are using these pins. So PWM, it is ideal for controlling the LED brightness for motor, then motor speed, servo position, buzzer volume, and you can connect any other output element for that. So example here is analog right, 128. So we are using the pin number 9. Here we are using the pin number 9. Then value, it will range from 0 to 255. Okay, so 0 means it is off, and 255 means it is on. So 128 means it is 50% of the duty cycle, so the signal will be on for 50%. Now here, this is the connection, that is, here I have connected a LED, then I have connected a multimeter, and this is the oscilloscope in order to see the waveforms, and this is to see the voltage. And here you can see the brightness of the LED changes with the change in the duty cycle. So here I have connected a buzzer. Okay, in the previous one we have connected only the LED, so we can observe only the change in the brightness. Here we can hear the change in the sound as the duty cycle changes. Now here I have connected a DC motor. Okay, here it will change the speed. We can observe the change in the speed of the duty cycle of the DC motor as the duty cycle changes. You can also connect a servo motor, okay, here, and you can observe the changes. So now we'll see a program in Tinkercad. So here you can whatever designs you do, okay, or whatever experiments you do, everything will be saved. Now how it will be saved, I'll show you. So here you can see this icon. No, you have to click on this icon, Tinkercad icon, and you will get this dashboard like this. Now you have to click on the designs. If you click on the designs, you will get all the things which you have done here. Okay, all the experiments which you have done, or the circuits which you have done here. Now I'll select this one because I'm doing PWM, so I'll select this one. That is, I have already done it for the previous video. Now today we are looking for the different program. Connection will be same. Now this is what I have done. So I will tinker this. Okay, you have to click on tinker this. Now we got this. We'll see whether the code is same or we have to write the new code. Okay, already I have copied here the code which I want to show for the 0% duty cycle, 25% duty cycle, 50%, 75%, and the 100%. Now we'll simulate it. See, the motor is rotating. It's now here. I will stop this. Now I'll connect a buzzer for this. Okay, search for the element buzzer. So this is the buzzer. Okay, now I'll connect the buzzer. So here this is the positive 1, positive to 5 volt. I'll change the color of this. I'll make it red. Now here it is negative, so I'll connect it to the ground. I'll make it as black. Okay, now I'll start simulating. See, you can hear the sound. Okay, it is changing for 0%, 25%, 75%, 50%, 75%, and 100%. You can also see the signal here. Now I'll stop it. I'll connect a DC motor here. Okay, here. Now again I'll connect it. So this is the ground. Sorry. This is ground. And this is VCC. I'll change it to red. Now we'll start simulating. See, you can see all the elements here. The brightness of the LED is also changing. Okay. See here. You can observe a change in the brightness of the LED. Okay. You can hear the sound of the buzzer. Then you can see here the rotations. Okay. You can see the rotation of the servo motor also. Right? So this is how you can connect all the elements for the PWM signal. Okay. So here what we have done, we have taken 4 output elements, that is 4 actuators: LED, servo motor, DC motor and buzzer. You can connect other elements also. And this is a multimeter, this is a oscilloscope, and this is the small breadboard LED, and one resistor you have to choose. So this is about the PWM experiment using the Tinkercad.